Hello friends, welcome you all in the another lecture of structural analysis, and we are looking into influence line diagram, which is also called as ILD. So in the previous classes we have seen the maximum reaction in the girder, maximum shear force positive and negative at section, and we have seen the maximum bending moment under given load 50 kN meter. Now today we will see the maximum bending moment at given section. So the given section, we know that given section is C, 4 meter from A and 11 meter from B, having the girder of 15 meter. So we will draw the girder and we will draw the section, and we know the train loading which is moving from left to right, 40 kN, 50 kN, 60 kN, 60 kN, 20 kN at a distance of 1 meter, 2 meter, 1.5 meter and 1.5 meter respectively. Now at what load we will get the maximum bending moment at section, that we have to determine. By putting the load of 40 kN, are we getting the maximum bending moment? By putting the 50 kN load, are we getting the maximum bending moment at section? By putting the 60 kN, are we getting the maximum bending moment? So instead of checking this all individual load by keeping the section and by calculating the maximum bending moment, we have one check, that we have to compare the LHS side and the RHS side, and we have to determine on what load and we have to determine exactly on what load we are getting the maximum bending moment at a one stroke. Okay, so LHS side at this section, if you see, the LHS side is A to C, having the length of 4 meter, and RHS side is having the length of 11 meter, which is this one, CB. Okay, so we will check LHS side and RHS side. We will compare this, and how we have to check is the load rolled off divided by the span of the section. Okay, so the train is moving left to right. So first load we will which will be moved is 40 kN. So this load will be in the RHS side and rest of the load will be in the LHS side. So that we have to check. So at RHS side 40 kN load is moved, and the CB span is having 11 meter length. So 40 divided by 11 we will do this. Then on the right side, on the left side, the remaining load is 50 kN, 60 kN, 60 kN and 20 kN divided by the length of AC span, that is 40 meter. So we will do this calculation. So after getting the calculation, we will getting the value, this 42.5 and this 3.65. If you compare these both values, you will find the LHS side is larger than the RHS side. So here, due to this 40 kN load, whatever bending moment we are getting, that is not maximum bending moment. So we will skip this. We will transfer this 50 kN load to RHS side. So in RHS side, two load will be there, 40 kN per meter, 40 kN and 50 kN divided by 11, and the rest of the loading will be on LHS side, 20 plus 60 plus 60 divided by 4. And if you calculate this, we will get this value 35 on the LHS side and 8.18 on RHS side. And again we are getting LHS side is larger than LHS side. So it is also, we can say that by this load 50 kN, if you put this load, so by keeping this load 50 kN on C, whatever the moment we are getting, that will be not maximum. Okay, so we will move further and we will transfer the 60 kN load to the LHS side, and the value will be 40 plus 50 plus 60 divided by 11 and the remaining load is 20 plus 60 divided by 4. So the value which will be get is 20 on LHS side and 13.63 on RHS side. Again this LHS side is greater than RHS side, so we have to keep this calculation unless and until when we will get the RHS is larger and LHS is smaller. Okay, so when this sign is changes, on that value we will keep on this C section. So we will proceed further. We will transfer the 60 kN load to the LHS side. So on LHS side, this will be 40 plus 50 plus 60 plus 60 divided by 11. So value we are getting is 19, and on our LHS side there is only one load, 20 divided by 4. So the value we are getting is 5. And now the sign is changing. So RHS side is larger than, is greater than this LHS side. So by keeping this 60 kilonewton load, keeping this 60 kilonewton load on C section, whatever bending moment we are getting, that will be maximum bending moment under given section. So what we will do, we will again draw the beam diagram. At C, this side is 4 meter and the right hand side is 11 meter, and at C we will keep this 60 kilonewton load. On the left side of this, 20 kilonewton load is there at a distance of 1.5 meter, and at right hand side there are 3 load, 60 kilonewton, 40 kilonewton, 50 kilonewton and 40 kilonewton at a distance of 1.5, 2 meter and 1 meter to each other. Okay, now we know that there is one bending moment diagram for this. So maximum bending moment diagram we will draw exactly below at this C point where the 60 kilonewton load is situated. There will be the maximum bending moment. So this will be the maximum bending moment point, and we will just mark this magnitude of all the loading condition, and we will name it as Y1, Y2, Y3, Y4 and Y5. Now we know that at this point the bending moment is AB by L. So the value of A we know. A is the left hand side distance, that is 4 meter, and B is right hand side, that is 11 meter. So directly we can calculate the value of Y2 by putting this value AB by L. So before getting into the calculation of Y1, Y2, Y3 and Y4, we will calculate the remaining distance. So at C, at a distance of 1.5 meter, there is one load 20 kilonewton. So remaining distance will be 4 minus 1.5, that is 2.5. And at right hand side, the remaining distance is 6.5. This distance is must when we are calculating the value of Y1 and Y5. So this value we have to calculate first. Okay. So now we will move to the calculation of Y1, Y2, Y3, Y4, Y5. So for calculating of Y1, Y3, Y4 and Y5, we must know the value of Y2. So first we will calculate the value of Y2. So Y2 of Y2 is AB by L. A is 4, B is 11 and L is 15. So Y2 we are getting as 44.15. So by using the advantages of symmetry of triangle, we will calculate the remaining values Y1, Y3, Y4 and Y5. So Y1 will be 44 divided by 15 divided by 4 into 2.5, and that we are getting is 11.6. Y3 44.15 divided by 11. Now at this point we are taking this 11, and at this point we are taking as 4. At Y1, if you consider this Y1, so Y1 is on the left side where the distance is 4 meter. Okay, and remaining Y3, Y4 and Y5 are on the right side, which having the length 11 meter. That's why on Y3, Y5, Y4 and Y5 we are taking this 11 meter, and at Y1 we are taking this distance as 4 meter. Okay, so at Y3 44 divided by 15 divided by 11 into 9.5. So this Y3 is situated at a distance of 9.5. 11 minus this 1.5, we can say this distance is 9.5. So 9.5 we are getting this value as 38.15. Then we will calculate Y4. 44 divided by 15 divided by 11 into 7.5. So this Y4 is situated at a distance of 44 from 7.5 is 7.5 meter from B. So this we are taken. So we are getting the value as 2, and then Y5 44 divided by 15 divided by 11 into 6.5. This distance is 6.5 at this Y5. So we are getting this value as 26.15. So now we will take this value and this loading condition, we will multiply with this loading condition to calculate the maximum bending moment at section C. So we can say that this, we will keep this 20. So 20 multiply this Y1. So Y1 is 11.6. Then 60 multiplied by Y2. So Y2 is 44.15. Then this 60 multiplied with this Y3. So Y3 is 38.15. 50 multiplied this Y4. So Y4 is 2. And 40 multiplied with this Y5. So Y5 is 26.15. Okay. So this 20 into 11.6 plus 60 into 44.15 plus 60 into 38.15 plus 50 into 2 plus 40 into 26.5. If you do this calculation, you will get the maximum bending moment 534 kilonewton meter at section C. Okay, so at this point we can say maximum bending moment at given section, whatever the section is given, you have to compare the LHS side and RHS side, and on what and we have to see on what load this sign is changes, and by keeping that load on section C, we will get the maximum bending moment. So for this I am uploading this on YouTube, and I am sharing and I am posting the link of the previous videos lectures in the description of this video. So go through that and have a clear idea about this influence line diagram. So in the next video, which will be the last video of this influence line diagram, we will see the absolute bending moment. Thank you very much.